Hello my dear students, welcome to my channel Take It Seriously, and I hope you all must be taking your study seriously. Yes, fun is something you cannot do away with and you should not do away with, but be serious about your studies and focused about your studies. If you consider life as a wheel, then your education is the center of that wheel, and all other realms of life, all other spokes of your life are connected to that center, and the wheel of life revolves around that center. So you need to be really serious, really cautious and determined about that center. You should make all your efforts to make that center strong, okay, so that your whole life gets strength. Trust me, whatever walk of life you will choose in future, whatever career you will choose, your education will surely give you confidence. It will surely boost up, level up your confidence, your personality, and it will give you that never backing off attitude, never saying no attitude, right? So let's cut this philosophy and come to the point. So today's class is part of linear equations in two variables, and we'll be discussing three things. So the first thing that we will be discussing is formation of linear equations in two variables. Second is plotting graphs of linear equations in two variables, and third, we will end up the chapter with discussing lines parallel to y-axis and x-axis. Okay, so without beating around the bush anymore, let's quickly get started. So the first concept of the day is formation of linear equations in two variables. A situation is given in front of you, and for this situation you need to form a linear equation in two variables. So let's see the question. The age of father is 4 more than twice the age of his son. So father's age is 4 more than twice the age of his son, and we need to form an equation for this situation. So let's do it. Okay, so we don't know the age of the father, we don't know the age of son. So let's suppose the age of father is x and age of son is y. So let age of son, age of father be x, okay, and age of son be y, right? So we have assumed the age of father as x and age of son be y. Okay, now what the question says, according to the question, what is this ATQ? ATQ is for according to the question. So according to the question, father's age, that is x, okay, so x is 4 more than twice the age of his son. So x, father's age, is a 4 more, means plus 4, okay, 4 more than twice the age of his son. So twice the age of his son is 2y, and it is 4 more than twice the age of his son. It means x is equal to 2y plus 4, okay. So this is a linear equation for the above mentioned situation. Simple, okay. So let's move to another question. So here is another situation for you, and you need to form a linear equation in two variable for this as well, okay. So let's see what the question is. The taxi fare in a city is, okay, so the taxi fare in a city is given for the first kilometer, okay. So for the first kilometer, the fare is rupees 8, okay. For the first kilometer, the fare is rupees 8, and for the subsequent distance, it is rupees 5 per kilometer, okay. For the first kilometer, it is rupees 8, and for the subsequent distances, it is rupees 5 per kilometer, taking the distance covered as x kilometer and the total fare as y, okay, y rupees. So write a linear equation for the given situation. Okay, so this question is a bit tricky. So let's understand the question first. So what it says, the taxi fare, okay. So how much fare would be? Taxi fare would be is for the first kilometer. Let's say you took a ride by that taxi and you travel 4 kilometers. Let's take an example, okay. You just travel 4 kilometers, first kilometer, second kilometer, third kilometer, and this one is 4 kilometers. So you took a ride for 4 kilometers, okay. So how much fare you would be paying to the taxi driver? How much fare would you pay? So for the first kilometer, the taxi fare is rupees 8, okay, and for the subsequent distance it is rupees 5 per kilometer. Means for this 1 kilometer it is rupees 5. Then again for this one it is rupees 5. Means after the first kilometer the taxi fare is going to be rupees 5 per kilometer. Okay, so for 1 kilometer we paid rupees 8, and for the remaining, so out of 4 kilometer we have paid for the 1 kilometer, first 1 kilometer. Okay, so now we are left with 3 kilometers, right? And for the rest of the 3 kilometers we need to pay rupee 5 and rupee 5. Means rupees 5 into 3, right? So 5 into 3, that is 15 rupees 15. So how much fare we need to pay? We need to pay rupees 8 plus rupees 15, that is 15 plus 8 is what? 23. So we need to pay rupee 23 for if we travel a distance of 4 kilometer by that taxi, right? But the situation is different. So you got the question, right? So for the first kilometer rupees 8 is being paid, and for the subsequent distances rupee 5 per kilometer fare is being paid. Okay, so now see how much distance, what they are saying. Take the distance covered as x kilometer. So let's say you are traveling a distance of x kilometer and the total fare comes out to be y. So let's make a linear equation for this situation. Okay, so what they are saying, that you covered a distance of x kilometer, right? X kilometer. So the total distance that you covered is x kilometer. Fine. So for the first kilometer fare, how much fare will you pay for this x kilometer? For the first kilometer you are going to pay rupees 8, right? Okay, so out of x kilometer you have already paid for the first kilometer. So how much distance is left now? X minus 1. So out of x distance you have already paid for the first kilometer. So what distance is left? X minus 1 kilometer is left, still left. Okay, so how much distance is left from here to here? X minus 1 kilometers are still left, and for the remaining distance, for the remaining x minus 1 kilometer, the taxi fare would be rupees 5 per kilometer. So for 1 kilometer thereon it is rupees 5. So for x minus 1 kilometers, so how much would be the fare? Into 5, right? So total fare for x kilometer will come out to be rupee 8 plus x minus 1 into 5. X minus 1 into 5. So that is, you can say x minus 1 into 5. So same. Okay, so total fare. So what they are saying, assume that total fare is y. So y is equal to 8 plus 5x minus 1. Now just solve it, simplify it. So 8 plus 5x minus 5, and now y is equal to this much. So what it will become, 8 minus 5 is 3. Okay, so we'll bring y to that side. So 5x plus 3 minus y is equal to 0, or we can write it as 5x minus y plus 3 is equal to 0. So this is the linear equation in two variables for the given situation. Clear? Okay, fine. Let's now move to the next topic of the day, that is plotting graphs of linear equations in two variables. So the next concept is plotting the graphs of linear equations in two variables, and this is really important because you will surely get one question in your examination on this topic. Okay, so here is the question for you. You need to plot the graph of this equation on the graph. You need to plot this equation on the graph. So before we do this, before we attempt this question, let's understand the basic basic philosophy of a line, basic concept of a line. Okay, so let's take a line in space. Okay, so there is a line. Okay, let's say this is line L, right? So this is a line. So what do you understand by this line? So this line, okay, is made up of a lot of points, infinite number of points. Okay, so these points, okay, you remember in the part 1 of this chapter, I told you that a linear equation in two variables will surely give you a line. Okay, will surely give you a line, and a line, or linear equations in two variables will have infinite number of solutions. What those solution means? These solutions are the points. You can see a line is made up of a number of points. A number of points will lie on this line. It means this line will have infinite number of solutions. Okay, infinite number of solutions means it will have, a line will consist infinite number of points. So whatever point lies on this line is its solution. Okay, this much is clear. Now, in order to plot a line, okay, how many points do you need? Let's say if you have 1 point, let's say you have 1 point. How many lines can you plot? You can plot infinite number of lines, right? Infinite number of lines that will pass through a given point. But if I ask you to plot a unique line, how many points do you need? Minimum you need 2 points to plot a unique line. Okay, you need 2 points at least to plot a unique point. So point A and point B, 2 points, right? So if you have 2 points, you can surely draw a line, a unique line. Okay, a unique line. So to draw a line, the first thing that we need to keep in mind is that we need 2 points. Okay, 2 points. The maximum points you can obtain for yourself, but 2 will do its work. Okay, so 2 points you need to plot the graph of a line or of a linear equation in two variables on the graph. Okay, so this concept, 2 points concept, this concept we are going to use in plotting the graph of this equation, right? So you need to plot x plus y equal to 4 on graph. This equation, we know that this is a linear equation in two variables and it will surely give us a line. And to plot a line, we need 2 points. Okay, so we need 2 solutions. So how we are going to obtain those solutions? Let's make a matrix here the way we did in part 1, right? So we are making a matrix here. This is x, this is y. So let's assume x for a moment something, and then find the value of y, and then you assume y something, and then get the value for x. So what I mean by that? At x equal to 0. So when x is 0, okay, so y will be, x is 0, then y is equal to 4, right? So y is equal to 4. So when for this equation at x equal to 0, y becomes 4. Okay, so this is my first point. Now I need second point also. Second point means second solution. So let's assume y as 0. So at y is equal to 0, x plus 0, right? X plus 0 is equal to 4. So x will become 4. At x equal to 0, y is 4, and y is equal to 0, x is 4. So x is 4 at y is equal to 0. So this is my second point. And that's all I need to plot the graph of this line. So I have my 2 points, point A and point B. What I mean? Point A, that is 0, 4. Okay, this is how we represent a point. 0, 4. And point B is 4, 0. So I will plot these points on graph, join them, and I'll get my line. So let's plot this line on graph. Okay. Okay. So we need to plot this line x plus y is equal to 4 on the graph, right? And in order to plot this, we have already found 2 points. Okay, so these are our points. So point A and B are the points that we need to plot on graph. Okay, so these are the 2 points, and we need to plot these 2 points on the graph. First we'll plot these 2 points, and then we will join them and we'll get our line. Okay, now first of all, as you see, this is the graph. Okay, so this is the graph paper, right? And on this graph paper, you need to first of all draw x-axis and y-axis, right? So this is your x-axis and this one is y-axis. Make sure that the corners of x and y-axis are arrow shape. Many a times the students forget to put these arrows, because these are lines. Okay, these are not line segments, so you need to make sure that the arrows are there. Okay, so first the x-axis and y-axis you need to plot, and then you need to give some numbering to them, some scaling. Okay, so here my numbers, you see the numbers here are 0, 4. So these are the numbers that I need to plot. So I need to choose a scale which can fit these numbers.
Okay, so the scale I have chosen is 1 2 3 4 5 6 because I know whatever points I have, I can easily plot these on the number line. Okay, right? So these are the scaling is done, excesses are named. Now I need to plot my first number, that is 4 comma 0. Okay, so 4 comma 0, 4 comma 0 means x is 4 and y is 0. Okay, so x is 4 and y is 0. So x is 4 and y is 0. This is the point. Okay, so this one is the point, right? So this is the point and let's name it. So we have named it a 4 comma 0, right? Now let's plot second point, that is 0 comma 4 b. So 0 comma 4 means x is 0 and y is 4. So x is 0 on y axis, right? So 0 comma 4 is this point. Okay, so this is the point 0 comma 4 and let's name this point. Let's name it. So this is b 0 comma 4. So now we have our 2 points. Okay, so what we'll do next, we'll join them to get our line. Okay, so we have joined these 2 points and we have obtained our line. So this is the line we are talking about. So this is x plus y is equal to 4. So once the line is drawn, you need to just write down the equation of that line on that equation of that line on top of it. Okay, so now the graph is complete.
So here is a question for you. So the question says, if 3 comma 4 lies on the graph of this equation 3y is equal to ax plus 7, okay, find a, right? So this is the equation and this point lies on the graph of this line. So if this point will lie, if this point will lie on the graph of this line, right, it means this point is its solution. Okay, and if this point is its solution, then it means this point will surely satisfy this equation, right? So if it will satisfy this equation, it means in place of x we will put 3 and in place of y we'll put 4 in this given equation and we'll get the value of a. So let's do it. So we'll replace x with 3 because this is the point. So what is the point? Point is 3 comma 4. Okay, so this is our x and this is going to be our x and this is going to be our y. So this is our equation, 3y is equal to ax plus 7. So in this equation, in place of x we'll put 3 and in place of y we'll put 4. Okay, so 3 into 4 is equal to ax, x is 3 plus 7. Let's solve it to get the value of a, right? So it's 12 is equal to 3a plus 7 and 3a is equal to how much? 12 minus 7 is 5. Okay, 12 minus 7 is 5, yes? Oh yeah. And a is equal to 5 by 3. So this is the value of a. Simple. Okay. So we're done with the graphs of linear equations in 2 variables. Let's move to the last concept of the day, that is lines parallel to x-axis and y-axis. Okay, so here you have a question in front of you. You need to plot x equal to 3, this equation x equal to 3 on the graph. Okay, so let's understand this question. So you see this equation x equal to 3, this is independent of y. It means there is no y variable. Okay, it means it is independent of y. Means if y take any value, for whatever value of y, it's going to be the same. X is going to be the same because it is independent of y. Y is not affecting this equation. Y is 0, x will be 3. Y is 4, x will be 3. Y will take any value. Okay, any value. X is going to be same. X will be 3 in all the situations, right? So in order to plot this equation on graph, we need to find 2 points, right? So what our points will be. So let's say this is x and this is y. As it is independent of y, so whatever value of y you give, the x will remain constant. It will remain 3. So at y is equal to 0, x is going to be 3. At y is equal to 1, x is going to be 3. For whatever value of y, the x will remain constant. X will remain 3. You're getting this point? That for all the values of y, x will be constant, that is 3. Okay, now let's plot this on graph. Let's say this is the Cartesian plane, okay, and this is Cartesian plane, and it has coordinate x-axis and y-axis, right? So it has x-axis and y-axis, and I need to plot these 2 points because I need to plot the equation of this line. So I need to plot these 2 points and then I'll join it, and then I'll get the graph of the equation. Now first point is 3, 0. So I need to mark a scale. So let's say this is 1, 2, 3, 4. Again 1, 2, 3, 4, and here minus, -1, -2, -3, -4, -1, -2, -3, and -4, right? So once you have you have done the scaling, now let's plot these points. Okay, the first point is 3, 0, right? 3, 0 means x is 3, y is 0. So this is the point. So this is my point. So this is how I plot point on graph. Okay, so this is the point A, 3, 0, right? The first point is 3, 0. Second point is 3, 1. X is 3, y is 1. So x is 3 and y is 1. So this is the point, right, just above it. So this is my point B, 3, 1. So I've got 2 points, this and this, right? I need to join them and I'll get my line, right? So you see such line, x equal to 3 is this line, which is parallel to y-axis, okay? This line is parallel to y-axis and it is at a distance of 3 from the y-axis. It is x equal to 3. It is at a distance of 3 from the y-axis, and this line is parallel to y-axis. So this line is x equal to 3, okay? So if the line is x equal to 3, it will be parallel to y-axis and it will be at a distance of 3 from the y-axis, okay? So this line x equal to 3 will be parallel to y-axis, okay? Will be parallel to y-axis and it will be at a distance of 3 from the y-axis, right? It will be parallel to y-axis and will be at a distance of 3 from the y-axis. What if the case is this? What if I ask you to plot this on the number line? So y equal to 4 is one such line that is parallel to x-axis, right? You get it? X equal to 3 parallel to y-axis. Y equal to 4 or y equal to any value, 5, y equal to -1, y equal to 0, any value, any line, any equation this way. So it will be parallel to x-axis, okay? So y equal to anything is parallel to x-axis, okay? Let's say if I talk about y equal to 4, so this line will be parallel to x-axis and it will be at a distance of 4 from the x-axis. Are you getting? Parallel to x-axis and will be at a distance of 4. So how it will look like? Y equal to 4 will look like, it will be a line parallel to x-axis and it will be at a distance of 4 from the x-axis. You getting? Okay. Now let's quickly see what will be the equation of x-axis and y-axis, right? So equation of x-axis, if I ask you, yes, I'm asking you what is the equation of x-axis and y-axis, right? So this is the Cartesian plane. This is the Cartesian plane. This is x-axis. This is y-axis, right? So if question is find the equation of x-axis. What is the equation of x-axis? So x-axis, at x-axis, all the values of y is 0. So wherever, like any point on x-axis, y is 0. So what is the equation of x-axis? Y is equal to 0. Okay. And what is the equation of y-axis? For this axis means at y-axis, any point on y-axis, x is 0. So what is the equation of y-axis? X equal to 0. You get this point? X-axis equation, y equal to 0. Equation of y-axis, x equal to 0. Clear? Okay. Okay. So this is the last question for today's session. you have to give the geometric representation of y equal to 3. Okay, geometric representation of y equal to 3 as in equation in two variable, first case, and in one variable. Okay, so this question looks tricky, but it's really simple. Okay, what they're asking you, y equal to 3, you need to give geometric representation. You need to draw it geometrically as an equation in two variables. So two variables, we already know y equal to 3 is a line parallel to x-axis, right? So what you will do, you will just draw for this thing. For the first part, you will take the graph and you will start plotting the graph of this equation. You will go like this, plot, just number the x's 1, 2, 3 and 4, and again -1, -2, -3 and so on, 1, 2, 3 and 4. Okay, always make sure that you are just naming the x-axis, so x-axis and y-axis, right? So you have named the axis, you have marked the scale, and now you need to plot this line y equal to 3. So y equal to 3 is a line parallel to x-axis, right? Y equal to 3 parallel to x-axis, and it will be at a distance of 3 from the y-axis, right? So this is the line y equal to 3. So this is the geometric representation of y equal to 3 in two variable, right? But now you need to represent this lines in one variable. Okay, as you can see, y equal to 3 is already in one variable. So what you have to do, you just need not to panic. Okay, you just need to draw a line, one dimension, one line, simple number line, and name it as y equal to 3. So this is the number line, right? So we are just naming this line as y-axis, simple, right? So this number line, we are naming it as y-axis. Okay, and you need to plot y equal to 3. So this number line, you need to plot y equal to 3. So this is the number line, 0, 1, 2 positive values towards the right, 3, 4 and negative values towards the left. Okay, and now you need to plot this point y equal to 3. So this is the point y equal to 3, simple. So this is the geometric representation of y equal to 3 in two variable, means coordinate axis, both axis, y-axis and x-axis, and in one variable, we'll just draw a simple number line because it is a equation in one variable, simple. Okay, so my dear kids, with this we have come to the end of this video. Before leaving, I would request you to please like, share and subscribe to the channel, and we'll see you in the next video. Till then, bye bye and take care.